After the creation of boundary layer, there is a unique types of velocity that fluid particles goes through. We call it velocity profile. Let us visualize it. Consider a fluid entering a circular pipe at a uniform velocity. A fluid in motion comes to a complete stop at the surface and assumes a zero velocity relative to the surface. That is, a fluid in direct contact with a solid sticks to the surface, and there is no slip. This is known as the no-slip condition. The fluid property responsible for the no-slip condition and the development of boundary layer is called viscosity. The layer that sticks to the surface slows the adjacent fluid layer because of viscous forces between the fluid layers, which slows the next layer, and so on. So, the flow region adjacent to the wall, in which the viscous effects are significant, is called the boundary layer. But in the blue region, there is no boundary layer surrounded, so the frictional effects are negligible, and the velocity remains essentially constant in the radial direction. This blue region is called irrotational flow region. As the fluid passes by, the thickness of this boundary layer increases in the flow direction until the boundary layer reaches the pipe center and fills the entire pipe. Remember, at first, water velocity is just a function of pipe length and pipe radius, but when the boundary layer fills the entire pipe, then velocity will just be the function of pipe radius. Keep that in mind. So, when velocity varies only on radial direction, then velocity profile develops, which makes calculation easy, as it only depends upon one direction. That is pipe radius. The region from the pipe inlet to the point at which the velocity profile is fully developed is called the hydrodynamic entrance region, and the length of this region is called the hydrodynamic entry length. So as you can see, the velocity profile, it have different velocity along the radius of pipe. For example, at the center of pipe, r equals 0, velocity is 4 meters per second, and similarly, at the complete radius of pipe, velocity is 0, which is due to no slip condition. You can see how the velocity varies radially, and if you plot every velocity as a function of radius, you will get an parabola. The velocity profile in the fully developed region is parabolic in laminar flow and much flatter, or fuller, in turbulent flow due to eddy motion and more vigorous mixing in the radial direction. Please subscribe for more fluid mechanics animation.